Good morning, June 14th. Here comes Edgar. Whenever you're ready, Chris, you should be able to share and take it away.
All right. Are you able to see my screen?
Looks great.
Okay. All right. So the particular topic I chose was bank closures, just because it was kind of relevant to me. Uh, and my research question is, what relationship, if any, does U.S. banks closures have to unemployment rates in each respective states? And I chose two particular periods. You had 2012, which the state of the economy was pretty much a growth recession. So comparing the employment rates to the bank closures there. And then, of course, 2020, which we recently went through the COVID-19 recession, and see if that at all played any role in closures and what that relationship looked like. So my data sources were both governmental sources essentially, and I was able to use that web link that you showed us in the tutorial there to connect my two spreadsheets. And here pretty much are my results. Looks like there was no correlation necessarily. R2 squared was less than 0.5%. So that was at least for 2012. And also the same was true for 2020. So looks like there was no relative relationship between the two. But it was still an interesting find. And here's just some of my findings I kind of spotted. My top 5 states for bank closures, I listed Illinois, Georgia, Florida, then Memphis and Tennessee was tied at 4, and then Maryland, Missouri, and Pennsylvania tied at 5th place. My top years that experienced bank closure was actually 2012, which I was kind of surprised that there was no relative correlation, because of course 2012 being the year that had the highest, but of course 2020 was nowhere to be found there. And then the top 5 states with the highest unemployment rates, which again they weren't on the top 5 bank closures, was Puerto Rico, Nevada, California, Rhode Island, and North Carolina. So just ultimately, what I kind of gathered from it were that unemployment rates doesn't necessarily affect banks as a heavy toll as you think. Even though it seems like that would be the case because less people are borrowing, but you know, I guess you got to remember that there's other clientele out there, businesses, they're still borrowing money, and other things like that are still going on.
All right. Can you put that back up, Chris?
Yes, sir.
Any questions from the group? Questions or comments? This, I mean, this has been 10 years. Y'all might have been young adults at the time. This was near and dear to my heart. The mortgage failures leading up to that 2012, that seems to be the peak of the bank closures as you identified, Chris.
Yes, sir.
The mortgage closures were staggering. I don't know if y'all remember back that far, but folks were walking away from their houses and everything, short selling, and it might have been like the closures were the result or kind of the after effect of all of that. So it lagged a little, Chris, you know, like, you know, the unemployment might have happened and which caused the closure to kind of lagged after that, or mortgage failures, and then bank closures lagged after that. So it may be something that's not immediately correlated, but is still a big indicator. You know what I mean? Your instinct might still be right.
Right. And then another phenomenon that the research didn't take account was a lot of the mergers and acquisitions that took place after that. So a lot of those failing banks kind of got gobbled up as opposed to just failing and closing. So that was kind of another saving grace that was there.
Gotcha. And if you could back it up to your slides, I just want to make a fine point here. Not picking on you, or maybe I am. On your about your X and your Y, your choice of your X axis variable and your Y axis variable. Um, did you intentionally choose them this way, or did you see them as it didn't matter which one was X and which one was Y? How did you pick those two like that?
The scope of it, I thought that would be the best fit. Should I have inverted those?
Well, that's what I wanted to talk to you about, because when you do one of these, the X axis traditionally is your independent variable that you're saying this happens, this X thing happens, and it causes a change in the Y variable. So what this chart is saying is that we have these bank closures and we're seeing the effect of those bank closures on unemployment going up the Y axis. But the way you briefed it, it sounded more like you were looking at the unemployment rate as the independent variable causing a change in bank closures on the Y axis.
Gotcha.
See what I mean? So, and Excel is weird when you go to do a scatter plot in Excel. If you have those columns reversed, it's like it I'm having a hard time remembering because I can't remember anything, but it seems like the first column will default to being the X axis, the independent variable, and then the second column that you choose to do a scatter plot like this will be the Y. And it's really hard once you've created the chart. There's no menu option that just says switch the X and the Y axis for me. You have to go back to the data and copy and paste that column and switch the columns in the spreadsheet, if I remember correctly. um, I put, I don't know, half an hour of googling into that last time, and it was not easy to just switch the X and the Y in Excel. Anyway, all right, cool. So no other questions from anybody? No. All right, you guys are making it easy on them. Thank you, Chris. Well done. Edgar, you ready to knock that out?
Yes. Can you hear me?
Sure can. Cloud and clear.
Good.
Cloud and clear.
Got a new headset and it's working now. So
podcast quality audio.
Okay. Let me share my screen. Can you see my PowerPoint?
Looks great.
Okay. So originally I wanted to focus on recreating a stat that I had seen previously, which was how movies were correlated into the amount of revenue they would make based on each state's political affiliation. So for example, I read a stat that Top Gun, the newest Top Gun, was doing better in primarily Republican states, primarily red states. But I couldn't find any data that was separated by states and movie revenue. So I took a little bit of inspiration from your presentation, Don, and I try to focus on average crime rate and weather, which is another stat that I had heard about before. So I kind of had an idea of what my results will look like. So I had heard that crime rate is correlated to higher temperatures. And so these are some of the questions I wanted to answer. How is crime rate correlated to average temperature, average precipitation, and the amount of wilderness area in each state? Here's some additional questions that I had. So do higher temperature states like Hawaii, Florida, Louisiana, and Arizona have higher crime rates than colder states? Same with these other states that have higher precipitation and a larger amount of wilderness. These are some of my sources. I primarily use Wikipedia for the crime rates, the states, the temperatures, and precipitation and wilderness areas. And these are some of the results. So this one here is crime versus temperature. And you can see there's a positive correlation, but not really very significant since the R2 is so low. It's only 4%. Which I thought was going to be more because I heard it was actually more correlated, but it's not. Same with precipitation, it's pretty small, R squared, say 1.36%. This one's the highest one, but my data looks kind of weird because the numbers were so large in the wilderness amount of acres and violent crimes. But it's 17%, which is a little bit more, but still it's a weak correlation. And as far as my findings, I have like the hottest states, the coldest states, the ones with the most precipitation, the least precipitation, the most wilderness, the less wilderness, and most crime and least crime. That's really it. And I had the same, I had the x-axis and the y-axis like yours, Don, so I think it's right.
Yeah, that's right. Because you can't, I mean, temperature is going to happen, right?
Yeah.
Temperature is a natural occurrence. So that would be a typical independent variable that goes on your x-axis. And then you look at what those average daily temperatures, how they would affect a dependent variable because the y depends on the x. So like something like tourism rates would depend on the climate or whatever it is you put, temperature, whatever that independent thing was you put on the x-axis. So no, that's right. I just wanted to in Excel, I know you guys don't do it. I don't think any of you do a lot of charting in Excel. But I just wanted to point out that when you've got when Excel's auto magic isn't working for you, like you've got a lot of white space going up to, I don't think you have any values in temperature under 30. You can click on one of those data points and format that series to change the scale so that it would only display between like 30 and 80, which can be problematic. You can mess up a chart by not doing 0 to whatever in a scale, like the Dow. They'll show the Dow Jones Industrial Average stock, and they'll show it between like 31,200 and 31,500, and they'll show it go down 300 points, and it looks like it tanked from max to 0 because the scale of the chart is a compression. You know what I mean? It's misleading. But as long as you point that out in your,
like here,
like go in Excel. Can you find that one that had the temperature going along the bottom?
Yes.
Let's see.
Which one's over here?
Temperature along the bottom. Yeah, there you go. Okay, now if I can remember the clicks, if you click on, there you go. The axis bounds. Click in minimum and say
30.
Yeah, if that's the no, you're formatting the y-axis right now, not the x-axis.
Oh, my bad.
So you want to put that back to the default or whatever, but I'm trying to think of how you like click down on the x-axis and say format axis or whatever.
Oh, yeah.
Yeah, like down there, and then format that. There you go. Now the minimum 30 and the maximum is 80 is fine.
Oh yeah.
See how now it stretches that out, makes it a little more reasonable, and your chart doesn't have so much whatever dead space, and you could do the same thing with the one where all the data was smashed into the left. Click on that that one, your x, make your maximum 16,000 or whatever. It's so big, it's exponential
Yeah.
or scientific notation. So I'm curious with that.
It's a little bit better, but it's missing a lot of
Yeah,
data
because
points.
it's scientific notation. Yeah,
Yeah.
it goofed up. So anyway, just wanted to point that out, that you can set that if Excel's magic isn't setting the scale the way you want it. You can modify that. So there you
Yeah.
go.
Okay. Also,
Cool.
I'll look at this and probably make it a little bit better.
Okay. But Chris, Edgar, if you would upload those, it seems like you already did, Edgar.
Yeah, I did it
Um,
yesterday.
yeah. So as long as I got something from you, this isn't an Excel certification course. So as long as I've got artifacts that you guys turned in your assignment, just
Okay.
upload those to that Excel assignment, and we will move on. Questions or comments right now before I pull up Workbench? Okay. That's why I'll pull up Workbench. Just kidding. One more look at my granddaughter, and she's so cute. Sorry, guys. I'll put that away so I don't accidentally share it again. Okay. Whoops, did I do that? Did I accidentally share a picture of the cutest little grandbaby I ever had? Let's see. I wanted to do a whirlwind of Workbench before I get into the actual SQL queries. So let me share. Yeah, share the whole screen. Okay, so once we don't need that tab. Once you get into Workbench and you have connected, you are connected to a server, a database server with your username and password. Now, inside of the server, you can have one or a bunch of areas for related tables to go together in. From a design standpoint, the generic term for that is a schema. What's the schema of your data? What's the schema of your database? I beg your pardon. So you put related tables, everything that has anything to do with each other, that are connected by those one-to-many lines and everything, and whatnot that we covered last time, you would put in the same schema. They can be almost duplicative. You could use separate schemas that have identical structure, but maybe one is like a test database and the other one is your live database, but they're duplicated so that your tests are running against an exact copy of the real world operational database design. So a schema, like I said, is basically a set of tables and other database objects contained within. I don't even know architecturally how the software does it, but if you are using a schema, like I'm double clicking, if I double click on Northwoods, it turns bold. Northwoods is the schema we'll be using for most of this, most of my presentation. But I've got another one up here called Northwind, which I know it's easy to get confused. Northwind, if I double click on it, it becomes the default schema, so that any tables I select from, any tables I reference now, it's going to assume they are in the Northwind database. So that's how you set your default schema. Make sure that the schema that you think you're querying the tables in is bold in Workbench. So double click on North Woods, and then underneath that, they all the schemas have the same drop downs as far as you're looking at tables. A view is like a logical table. You can write a select statement that will limit data and maybe reformat it. And then it looks like a table. And now you can query from that view instead of from the base tables. And views are a good way to, sometimes you want to do, limit data that people see to a certain department or whatever. So you'll create a view so that only those users can see the data you want them to see. And then you give permissions to the view, not to the underlying tables. So that's what a view is. Stored procedures are like triggers. You can write procedural code. Functions are just like writing your own function in Python or C++ or whatever. So we're not going to get into all of that. We're just going to learn SQL querying and table joins and subqueries and functions and groups and all that kind of built-in functions. So that's what that looks like. If you click on tables, you'll see this drops down. And in our Northwoods, we've got what, 7? 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7 tables. I'm kind of getting ahead of myself here, but anyway, that's how you make sure that you are clicking or that you're querying the correct schema. So once I'm in Northwoods, you see I have a course table. Now when I say, select whatever from the course table, it knows to use the course table in the Northwoods schema. I don't have to use schema.table.column or whatever to get to that. It defaults to the course table in the Northwoods schema. But I've got other schemas here. I got one called DWalker. Don't remember what the heck I was doing with that one. I was goofing around with some customer data. And I got schema 1, 2, and 3. Those are just blank so that I can do other stuff with them if I need to. Test, same thing. But we will be messing with, like I said, Northwoods database. We might do a little bit with the Northwind up here. It actually has, that's a Microsoft. If you've ever taught yourself any Microsoft Access, I think it comes loaded on Microsoft SQL Server. But the Northwind database I think the long name is like Northwind Traders. They're an import-export company. So you've got customers and salespeople and accounts and invoices and a lot of stuff that makes for a good tutorial. So you got a lot more tables in Northwind. And that one, there's lots and lots and lots of tutorials and whatnot out there. Like I said, there's a version of the Northwind database at W3 Schools. But it's not the exact same. But once you kind of get used to the theme, I think like the table and column names can be a little bit different, but many of the relationships are the same. So once you get used to seeing a Northwind database, they tend to look similar. This one is, I downloaded the create scripts in MySQL, not in Microsoft, and created it here. Okay. And some other things that Workbench can do for you is, like, when you first come in, you'll get a blank query window. And here you can, let me put away all this stuff I don't need. Don't need that. Don't need that. Don't need that. Don't need that. There, North Woods. That's what we're looking at. From here, you can write a query. Let's say, and we'll go over all this. And you hit Control Enter just like you do in Notebook, or you can run the lightning bolt. So I hit Control Enter and run that, and select star is every column from the course table. We'll get into all that. Automatically limits to 50,000 rows. If you need another tab, you see this this little sequel with a plus sign. That means give me a new tab, just like a fresh tab in Excel or a fresh tab in Chrome. So you click on that, and now you got another blank one, so you don't lose what you've typed over here in this first tab. So you can have multiple versions of queries going, so you don't lose your work. And when you don't need them, you just X them out right there. If you write a complex query that you want to save as a SQL script and run later, kind of like you can, save Python as a .py file and run that later with Python, you click the floppy disk, which no one uses anymore. Click the floppy disk, and it will save your query to a .sql, which can be handy. And then you can go back and open that. And if it's, because when we're doing nested subqueries, some of these queries can be one line. That's one line. A SQL query is one line of code ended by that semicolon. That one line of code can be 40, 50 lines on the screen. So they can get pretty complex. So sometimes you want to save those off as a script and run them later. And you can run more than one semicolon terminated statement in a script file, in a SQL script file, which I will show you momentarily. Okay, so like I said, the functionality we'll be using is basically get yourself one of these SQL query tabs and start, and that's what we'll use to type in these queries. And if you download the PowerPoint, generally speaking, you can cut and paste the query from the PowerPoint into Workbench to keep you from having to retype it, which you'll see me doing back and forth and back and forth. Okay. And there's a bunch of other stuff you can do with Workbench, to include drawing that ERD I showed you with the forks and the one-to-many relationships between the tables and all that. It will go into your schema and generate one of those for you automatically, and a bunch of other database administration kind of stuff that I don't really have use for or even knowledge of. Okay, so that's Workbench. That's our application we'll be playing with here for the next couple of class sessions. Let's see, back to Death by PowerPoint. Okay, we'll start with the basic of the basics, which is pulling data out of one table. Okay. And we talked about the Northwoods schema. So let me show you, and this is in, I think everything I'm showing you is in the Canvas classroom. If I bring up something on my screen that's not posted to Canvas or is different, please give me a firm shout out. Okay, so ERD, entity relationship diagram. Remember, an entity is, in relational database design, is your table. your table is an entity that relates to other entities. All right, so we got somewhere here, we have a North Woods ERD. Yeah, and this is not the system generated one. This is slightly larger and easier to read. If I could get it to pull up in Acrobat Reader. Okay, so this is Northwoods. What we'll be dealing with is a very simplified schema for like a college, and we will be looking at our core tables are students, where you see the in an ERD, you'll see the table name at the top, like in this this fuzzy gray block. It says student. Generally speaking, you'll see the primary key designated. That's the column in the database that uniquely identifies each row. So SID, S_ID for student ID is our primary key, and it's a 6 character number. And that's pretty sure that is generic. That's not necessarily a database specific data type. I don't think there's a number with 6 digits in that. This is kind of a design view as opposed to an actual implemented view. But here's all of our columns in the student table. So you got last name, first name, address, class they're in, date of birth, a student PIN, and then whenever you see FK, that means that that column, in this case F_ID, is a foreign key, which means it's a primary key in another table. So here we've got the FID related down here in the faculty table. What F_ID is faculty ID, so like an employee ID. So you have in this relationship line between student table and faculty table, you see the there's what looks like a little hangman character, 0, and that plus sign there, that T. That means that you can have 0 or 1 FID. So a student can either have no faculty ID identified. Oh, and what that is that's their advisor. That's in the student table, who is your primary faculty advisor. So if you haven't been assigned a faculty advisor, 0, the relationship 0, F_ID will be blank in the student table. And you see the up here at the student table, you see the big circle and the 3 forks. That's 0 or many. So that means that a faculty can be assigned as an advisor 0 or many times. So a particular faculty member might not be an advisor at all, or he might advise 20 students. That's just the relationship. So so yeah, this is something handy to have out when you are looking at different tables and you're trying to remember which piece of information, which attribute, which column is in which table, and how those primary keys and foreign keys relate. So that's the symbology, but you basically got students, faculties, and then some ancillary information. There's a major many-to-many mapping here that can cause a lot of fun, and that is You have courses up here in the upper right-hand corner, and that's going to be like, math 101, freshman comp 101, whatever. That's a course. So you'll have the call ID, which is the numeric code for it, the course name, which is the English language version, how many credits it is, and then notice you've got this weird looking relationship dash 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 relationship above the course table. That's an indicator of a self join or a parent-child relationship. And this one is particularly, it's a good example because a course can have a prerequisite course. You got to take Math 101 before you take Math 102, right? And this one, they're in the same table. So the relationship isn't external, it's internal to the course table, self-referencing. So you got courses. A course section is a particular offering of that course, taught by a particular faculty member on a particular day in a particular location, that sort of information. And then we talked about it before, you've got a lot of students and a lot of course sections. You got to figure out who's enrolled in which course section, and that's your enrollment table. That's where you join the student ID and the course section ID that can actually give you a roster for who is enrolled in which course section. And then there's some other stuff. When something's just hanging off of another table, it's very often like a lookup table where there may be like a code, but then you go out to this lookup table to get what the full value is. So like the term table, and then we've got a term is like fall 2007, spring 2020. That's what term we're talking about. This location table is a building. So you've got which building the course is being offered in, or well, it may or may not be offering a course at all. It's just a list of resources. So you've got building code and room number. Building code is which building is it. Room is which room number, and capacity is the seating capacity of that room. So that's our basic database. 1, 2, 3, 4, 5, 6, 7. So that's helpful that the ERD matches matches reality, which isn't always the case. You know what I mean? Your documentation doesn't always match your realistic database. But that's what we'll be using, and we can explore a whole lot of joins and functions and cool stuff using this database. And we'll dork around with some other ones so that you're not just seeing just this one database instance. Okay, well, we have come to break time. Any questions before we go on break?
No questions.
Doing good, guys? Okay. I'll see you back at 9:35. All right. Second hour, June 14th, we'll get back to it. So I showed everybody the ERD, and I also wanted to show you am I sharing anything? I'm not. Yeah, you're sharing too much information about your granddaughter, Dawn. Get back to business. Okay, let's share screen. That makes it easier. Let's see. Okay. The creation script, as I said, a SQL script can have is a file that contains any number of SQL statements. This one is a create statement, which is one of the things like we talked about last time you can do with SQL is to actually create tables. So this is the syntax for creating the location table, for example, and giving it the data type of each of your columns and any constraints on the data as far as you can make it only accept certain values so that the database will error and you don't have to check things as a programmer. The database will automatically kind of police itself and throw up errors that that will keep you from doing the wrong thing with a SQL statement or an application or anything like that. So yeah, so here's the create statements for all the tables to include their referential constraints, which key refers to which is a foreign key, yada, yada, you know. For terms, so there's 7 creates, and then we get down, and then there's, these are comments. There's anything that starts with I think it's 2 dashes, is a comment in a SQL script. So insert is another statement, just like select and just like create. You can insert into a table a list of values. So that's how we populated the database that we're working with with this SQL script. So you can start to see once you look at the you can go into the database and query up values to look at what's in the database, or if you have the create script, you can kind of check out what your data looks like using the create script. But each one of these are terminated by a semicolon. You know how in Python we don't really have a line terminator like you do in other languages and you do in SQL. So each one of these is technically a line of code, even though they're on separate physical lines. The semicolon is really what terminates things. And then commit, yeah, that's another SQL command that means save what I just did. You can do inserts and modifications and whatnot. You can insert data, change data, whatnot, and then roll that back. You can actually, there's a rollback command to undo what you did up to since the last time you committed your data. So it's kind of 2-stage. Okay, so that's that is our create script that made our little Northwoods database. Okay, so retrieving data, which is all about what we're going to be talking about, retrieving data. And we'll start with the simplest, which is from one table. So the syntax for a select statement, and select is a statement, insert is a statement, from is a clause, where is a clause that narrows down your select statement. So when I talk about it, I'll say, well, look in your from clause. You left something out of your from clause, or check your where clause. And there are, I think we got up to 7 or 8 different clauses that we will deal with in the course here. So that is your basic syntax. You select field name 1, comma, field name 2, or column 1, comma, column 2. You're from a table name, and then there's lots of different things you can do in your where clause to limit which rows you're returning or that the database will return in response to your query. But remember, to display something, it's got to go in select. Only columns that you put in your primary select statement will show up in results to that query. Okay, for example, we've got a select statement from our student table. So I will highlight that, hit Control C, pop back over to Workbench, and hit Control V. And I'll be doing this over and over and over and over and over again. Sometimes, depending, I think I've got it all fixed, but sometimes depending on which single quote character I used, it can come over as an apostrophe instead of a single quote, and it'll goof everything up. But I think I got my PowerPoints modified so that I use double quotes when I want to check a particular string literal. But just be aware, or anyway, when you paste something into Workbench, it's not always exactly what you thought it was going to be coming from Word or PowerPoint. So there I got, I'm selecting student underscore first, student underscore middle, or S underscore first, S underscore MI middle initial and last, and their GPA from the student table. And those have to be exact. If you misspell a column name or a table name, you'll get an error. So there's all of our students. And of course, their GPA isn't normally something you would store. That's normally something you would calculate on the fly every time. But for our little sample database, we've got it hard coded in there. Okay, and then Alt Tab back over to the PowerPoint. You may copy and paste this into Workbench. Okay, whoop, go back. Now, make sure we understand select star is a wildcard that means everything, all columns. So select star from location will select every row in the location table without limiting or anything. So all columns. And that's a really good way to just get to know your data. Select star from a table. The problem is when when that table has 85 columns and 3,000 rows, it can be a bit overwhelming. But for smaller tables, that's a great way to just look at everything. Select star from location. So you got your location ID, which is your primary key, your unique identifier. The building code, like BUS is like the College of Business, but then inside of each building, there's different room numbers, and there's a capacity associated with each one. For the sake of this little tutorial, capacity of 1 means it's an office, it's not a classroom. So it's kind of like a little bit of embedded intelligence. So there you go. Select star from table. Okay. And suppressing duplicate rows. You could have a table that has 10,000 rows, and there's maybe 6 or 8 different like shipping codes, maybe something either can ship by air, ships by truck, ships by rail, whatever. Sometimes you want to go just pull a list of unique values that exist in the table. It's not necessarily a list of all the possible values, but it's a list of all the the ones that are actually in the table. So if we go to the faculty table and we select F rank, which you may or may not know that in college, those professors have different ranks. I don't know if you remember, there was rules about how long you had to wait after after the bell. If it's a tenured full professor, you have to wait a half an hour or whatever. But if it's just adjunct or associate or whatever, you only have to wait 5 minutes. Anyway, so F rank, I want to say it was associate, then assistant, then full professor, and then like department chair or whatever. When I worked in academia. Anyway, here are all the F ranks, and you'll see we have 2 instances of full, 2 instances of ASSO, associate, and you got 1 assistant, 1 instructor. So that's pulling every row. That's pulling the F rank column or the F rank field for every row in the table. And when you want to make that and just pull the unique occurrences, you put that, I'll go and just type it in, select distinct, and you run that. And now it suppresses duplicates and you only get the unique occurrences. That's a really great way to check if you've got weird data. Oop, that's not what I wanted to do. That's a great way. Select distinct will find in a table of 50,000 rows, and you think something weird's going on, it'll find that wrong, that'll find that goofy occurrence in that table that's causing your processing to mess up. So select distinct column from table. Okay. So that's all rows and unique occurrences. And now search criteria. Your select from with nothing else will retrieve all the records, all the rows in a table. If you say star, it's every column. So select star from table is every row, every column, no constraints, no search criteria. But there's 2 basic types of a search criteria. Equals, exact, and then there's inexact, using inequality operators. But there's also an in, and there's between. So there are other inexact operators besides just less than, greater than, and less than, greater than, or greater than or equal to. Okay, so your search criteria, generically speaking, is your where clause. So you've got a select statement, and then we've got our from clause, and now our where clause. So here we're selecting the first name, middle initial, last name, and the faculty rank from the faculty table, where their F rank is ASSO. So we'll go over there and we will see who our ASSOs are. So I control enter to execute that. So our associate professors are Kim Cox and Philip Brown. Straightforward, right? Nice and English-like. And the order of these clauses matter. I'm introducing them in the appropriate order. If you start, if you tried to say from faculty, select first name or whatever, like a prepositional phrase in English or whatever, you start getting a goofy errors. So yeah, select from where. Where is how you limit your rows, and that where clause can get wickedly complex. Here we have a compound search condition or compound criteria. where we're going to pull a room out of the location table where the building code is bus, college business, and capacity is greater than or equal to the number 40, numeric literal. So you see how we got BUS in quotes and 40 not in quotes? That's because BUS is a string character and 40 is a numeric. And you'll get weird results if you get those confused. Okay, always puts an extra blank line in there for me. Okay, select room from location where building code is equals bus and capacity is greater than or equal to 40. So at this point, I'd like to point out what is convention, and depending on where you work, and there will be standards, just like we talked about for Python and data standards and naming things and what positions are called on the data analysis team. Every company has its own implementation. The way I was brought up is one way to do that when you're working with your select statements is to capitalize the keywords in the SQL language so that they kind of stand out on the screen. So I've got select from where and actually by convention, a lot of places will indent that. They'll indent the and so that the criteria, the multiple criteria kind of line up pretty like that. But you don't, I think some SQL implementations, they want the keywords to be capital, but I don't believe that's true for MySQL anyway. I haven't tested it certainly with all of them. But here we're selecting room, location, where building code equals bus. Now I want to show you this just to prove the point. We can put those on the same line, and that'll get room 105 and room 211. But for readability's sake and convention, generally that's the way I would write it so that they line up correctly, line up more readable. It's more readable that way. But I wanted to test real quick. I don't think like select has to be in capitals. Yeah, it doesn't have to be capitalized. And Workbench recognizes it as a keyword, and see how you'll see the keywords, the SQL keywords are blue, and your database stuff, tables and columns are black, and your string literals and numeric literals are orange. So it color codes this stuff. That's the other nice thing about working in an IDE, even though it's a pain to download and get it working through the firewall and everything. Working in an environment that's made for that language just has some features that are nice. Okay, so there we are, and I'll rerun that to make sure. Yep, room 105 and 211. So these are compound conditions, and of course, you can have an and you can have an or. Let's move on here. Everybody doing good? No questions so far? All right. Okay, so sometimes you want to know where your nulls are. And sometimes you want to exclude your nulls, which, as we have seen, can cause all kinds of weird things. So sometimes we want to know all records where the value of a field is null or not null. We may want to know all enrollments in courses where the grade is null, which means it has not been graded yet. We will select everything from the enrollment table. Remember, that's the one that actually has students assigned to course sections. Back to Workbench. I'll paste that in. Well, that ain't right. What happened? Pasted that in. I think it added it instead of overwriting it. Bam, there we go. Okay, so select star from enrollment where grade is null. We don't use equals null. It gives you odd returns. Let's see, control enter. So there we have student IDs and course section IDs. But remember, you don't have the student name in enrollment because that's over in the student table. So we'll get to those sorts of multiple table queries. So that's where everything is null. But if we does not use is, and equal sign does not get the right answer. So let's go look at that. It's goofy. So if I say equals null in MySQL, what do we get? That's kind of weird, isn't it? So remember that it's the is null. And then of course, you can say is not null, which is the opposite, the reciprocal. Okay. The next operators are, so this was, what did we do here? Yeah, we had something is equal to, and we had greater than or equal to. So you can do mathematical types of checks in your where clause, just like you would think. But sometimes you want to see if something is in a set, just like in Python. We learned of the in comparison in a list, in a Python list. Well, this is the same situation. We're going to select all columns from the enrollment table where grade is in A and B. The set is in the list of grades A and B, which would be the same as saying where grade equals A or grade equals B, right? It's the same thing, but it's more succinct to use it this way. And you'll see here in a day or two, when we do subqueries, you absolutely have to have that in operator. So this will show here's all so we got some A's, some B's, with a couple of C's, but we don't have any D's, E's, or F's. So here we'll pull just the A's and B's. And then it seemed like the other one was not in. Yeah, all I did was add not. Or you can say it's not in. So that just pulls up your C's, which would be the same thing as saying where grade equals C. So whichever way you come at it, it kind of just depends on the problem you're trying to solve. Okay. Okay, now here is an operator where something is like something. We're going to select columns from a table where the column is like, and then we use a character string. And generally speaking, when we work with a like operator, we are using wildcards to match character strings. So we'll be working with the %sign and the underscore. When you put those in a character string in your after your like operator, the percentage matches anything. from 0 to however many characters. The underscore matches one and only one character. And I'll give you some examples of that here. Okay, for example, if we were to select some columns from the term table where term underscore description like percent 2006 in quotes, that'll match anything as long as the term description ends with 2006, and that's it. Nothing after 2006, but as long as the last four characters are 2006, they'll all come up because the percent sign matches 0 to many characters. Okay, so that's that example. And here we go, of course. So we're going to select all columns, select star from term, where term description like percent 2006, just like in our example. I will highlight everything, hit Control V there. So select star from term where term description like percent 2006. And you'll see down here in the, so that got spring 2006, summer 2006, and fall 2006, because it doesn't matter how many characters came before 2006. Okay. And then over here, the percent sign can go afterward. So FALL percent sign means that it starts with fall and then FALL, and then anything can come after that and it will match that like operator. Select that, paste it into Workbench, and we will get all of our fall regardless of what year. Fall 05, fall 2006. So that's your percent sign wildcard operator.
Hey, Don.
Yes.
I have a question.
Sure.
Could you try that, but do a percent space percent?
Where? Like, can you see my screen now?
Yes, where it says fall percent, you
Yes.
just change that to percent, fall percent, or percent space percent.
Percent space percent. I can
Yeah.
change it.
I just wanted to see what happens.
It should pull anything. I'm before I do it, I'm walking through mentally what I think that I'm predicting what that'll do. Let's see. So that'll match anything and a space and anything else, but it wouldn't match anything that did not have a space in it.
Yes,
I believe that's
that's
what
what
that
I'm
would do.
thinking of.
We'll see. Yeah, it pulled everything.
Okay, thank you.
Sure. Well, you got me going now. Let me see. I want to see. Hang on just a sec. Once you get my curiosity going, select start from turn. Let's see what we get here. Okay, so status is one word, no spaces, no nothing. So so let's say where. And we, yeah, where status. Why? Oh, this is reminding me. Status is a keyword, and there's a way to do it. I think we get to that in a future lesson. Status is a column name, but it's also a keyword in SQL, which causes it to choke. I want to say if you surround it with like backticks. I'm getting ahead of myself. I'll use a different table if this doesn't work. Hang on. We're status like, and then we said percent space percent. semicolon. Yeah, that's going to goof up. We'll get to that later. That status column in this term table is problematic. It seemed like this is originally an Oracle database, and Oracle didn't have any problem with it, but MySQL kind of pukes. So hang on just a minute. Select star from, let's go back to student. I'll get there. You guys are on the clock. Don't mind me. All right. Yeah. So select star from student. And we were saying where something that has no spaces in it. Let's say S phone. And then percent space percent. What am I doing wrong?
You need a closing quote.
Thank you. You guys are sharp, keeping me on my toes. So that should return nothing, right? Because there's no blanks in S phone. Woohoo! Return 0 rows returned. Oh, that's another part of Workbench that you're probably going to want to kind of monitor. We have our results tile in the middle here, our result grid. It says in blue over here. But you've got a kind of a log file that tells you how long a query took to execute and how many rows were returned, and basically what you typed in. So this action output, this output tile down here can be pretty handy. Not sure if you guys noticed that one or not. Just another benefit of working in Workbench instead of in some web page that just happens to speak a little bit of SQL. 10:07, keep going for a little bit more. Does capitalizing matter? I believe you will find the answer is yes, as it should matter, because you can't expect, it doesn't matter. Why does that not matter? I sure was expecting it to return nothing. I'm gonna have to do some Googling. Why does capital F match with lowercase f in using the like operator? I'm gonna have to look into that. But sure enough, lowercase fall return the same results as uppercase fall. I'm trying to remember what my results from last time. Terms of fall for every record where the first 4 characters are fall. Oh yeah, here we go. And a percent sign can go. We've been using it at the beginning or the end, but of course, as we just saw with the percent blank percent, you can use it at the beginning and the end, and it will match anything that has the word systems in this example, anything that has the word systems in it. Now, why don't I have the whole query there? Anyway. Okay, so we're in the student table, And we're selecting, let's construct this thing. I apologize, guys. I thought I went through all these. Okay, so this will pull all the students from the student table where the second character is R. But as you can see, they're all that way. So it didn't really do anything. So if we wanted to pull let's say zip, S underscore zip. We wanted to pull people from a given area of the state. Let's say where well, they're all in 5-4 something. I'm looking here. Hang on. A certain number of characters. Yeah, I'm struggling to find a good example here, guys. We could say 5-4, 1, 2, 3, but that pulls them up because everybody starts with 5-4. Anyway, that's what the underscore character is good for. It matches a single character. But if there are more things before the R than a single character, it will fail that criteria. And we can combine wildcard characters, the % and the underscore. And in this one, there's 2 underscores. So we're pulling call ID from course, where call ID is like anything, and then a 1 and 2 more characters. So we got MIS space 1, 0, 1 is what matches. 0, 1 is what matches the blank blank in our where clause here, and 5, 5 CS space 55, and you can see they're offset by 1 character. So the % doesn't matter how many characters come before, but then we have to have a 1, and then 2 characters, doesn't matter what the 2 characters are. So you can combine those like that. But I'm curious if we just select star from course, what all kinds of different call numbers we have. Yeah, so if you wanted to pull like your senior level courses, your 400 level courses, what would we do to do that? Select call ID from course, where call ID like, and then we would say anything, right? So we need a %, anything, and then a 4, and then blank blank. Should just pull up, and then a close quote. Don't forget your close quote, Don. Should just pull up MIS 441 and MIS 451. Oh, and CS 452. There you go. So yes, you can combine wildcard characters. Let's see how much more we got to go on this one. A little bit. And guys, if you come up with a curiosity and you want to discuss well, what if we do, what if we do this or what if we do that, please just holler and we'll try it out and talk about it. Okay, so here's a straight ahead mathematical numeric comparison. Pull all the profs that make more than 50,000, which is all of them in the real world. Whoop. So all of those people make more than 50,000. But if we eliminate the where clause and we just select everything from faculty, that would have what? How many rows? 6 rows return. How many total faculty do we have? 8. So we got 2 folks. Ah, there we go. Jane Boston and John Blanchard that make less than 50. Okay. And here's another straight ahead mathematical comparison. We're selecting the last name and GPA from our student table, where for people that have less than a 2.5. Oh, so this is our academic probation. Control enter. There you go. Black and Connolly. Oh, 2.10, 2.19. Oh, your parents are going to be so upset with you. All right. 10:16. Yeah, let's go ahead, guys. Take 14 minutes. Check your email, check your texts. Get up, walk around, and we'll reconvene at 10:30. Okay, third hour, single table queries. All right, where were we? We were using good old fashioned mathematical operators like less than, greater than, less than or equal to, greater than or equal to. I want to say that not equals is the less than, greater than sign together. Let's see. Let's check that real quick. Okay, so 2.250. So let's say we're GPA is not equal to 2.250. Let's see what we get there. Sure enough, not equals, less than, greater than. And remember, like in Python, it's exclamation point equals. So yeah, depends on the language. That's why I'm constantly Googling, because I can never remember. Okay, where were we? Sorting. Okay, our next clause, particularly if you are generating a data file with your query. If the objective of your query is to generate results that you can then download and work with later. But also, you want to sort data so that when you look at your result, if it's the top or the bottom, you can kind of see it on your screen. Like I said, if you're dealing with thousands of rows, sometimes you want the one thing or the other to be sorted so that you can check it. Data because the database doesn't store stuff in any order that you can count on ever. So you always have to put an order by is the keywords we're looking for here. So we're down to yet another clause in our select statement. Select field names from table name, where, search condition, order by, sort key field. This is generic. These aren't actual tables. And that's how you sort the results of a query. So the sort field can be any field within the select clause. Depending on the data type, these numbers go by default ascending. Character string stuff goes alphabetically A to Z. Date fields sort by older to newer. Any in the select clause can be any field within the select clause. I was thinking you could order by something that you did not select, but I'm thinking out loud. Let's keep going. Okay. To reverse the order, we use DESC after our sort field to make it ascend in reverse order, descending. Okay, so here we've got a couple of examples. So we're selecting building code, room, and capacity. Again, all from single table here. Where capacity is greater than 50, and we're going to sort it by capacity, order by capacity. Plug that in. Order by capacity. 55 and 150. Just out of curiosity, if what the database will say. Oh, sure enough. By default, with no order by clause, it's wrong as far as sorting low to high. I beg your pardon for just 1 second. Okay. So our next example is just adding the descending keyword, which, as we know, puts it back in the way it wants to do it by default. But we're just lucky with that. So we add the descending keyword and we'll get it. I did something wrong. Select. Oh, yeah. Cut and paste. There. So yeah, now we go high to low. Descending keyword. Okay. Now, there's a formatting technique that we're going to use now. Back in the old days, when I first got going with SQL, you would write entire reports in SQL because the world was character based. Computer screens were not really any graphics. They were the same, 80 characters wide, 24 lines on the screen, the good old mainframe looking screens. And you could count on characters being, all the same width, which is not necessarily true for every font that you use in like Word or whatever. So you could write an entire report in SQL. You could set, headers and kind of, underline, and you could set page breaks and page numbers and all that kind of stuff. And you could do an entire report and make it good looking in SQL. Not so much the case anymore. I don't think there's a whole lot of that going on so much now. Y'all correct me if I'm wrong. If you're making pretty reports 100% in SQL, let me know. But it is still nice to be able to format your output as much as possible, so that when it winds up in that data file that you're going to go use in Excel or Tableau or whatever, that it looks as close to what you want it to look like as possible. So there's other methods to do formatting. We're just going to look at this one. It's called a column alias. So you know how these columns sometimes are goofy as heck name, so we want to consolidate that and make it something a little more readable. And the way you do that is to put an alias, a column alias, next to the actual column name. And then if you have multiple, you can say actual column name, column alias or head or the heading text, comma, and then the next one, then the next one, then the next one. So we're going to create a query on the location table that changes bulldog_code to building. It changes room to room space number and capacity, lowercase c, to capacity with an uppercase C, so that it's all nice and consistent. It'll display all rooms where capacity is greater than 30, sorted by capacity size. So I've got this on the next PowerPoint slide. So if we were going faster in the day, I might hack it out, but I'm just going to show you what we're talking about. So this is a typical assignment syntax where it says practice. That's typically the way I would put something in a homework assignment. And then you have to translate that to, sorted by, you have to translate that to mean order by, so the way that actually works, and I don't know why I use such a weird font here, but I do. So we're selecting building code space, and then in quotes, building. Rooms, space, room number, capacity, capacity. And when that comes out, you'll see, and where capacity is greater than 30, order by capacity. And when that comes out, doesn't really matter what font you paste into Workbench. It always comes out the same. So when you execute that, instead of seeing building code at the top like we do now, where we got BLDG_code, you will see the column alias or heading. So it makes it prettier. And then, like I said, if we're going to export these results to a data file by using our little export button here, the column headers will be the alias that you put up here. But now, yeah, there's a difference between, you can make a table alias. I don't want to get ahead of myself, but you can't use these aliases like as if they were the real column name. I don't think. I want to try something real quick here. Does anybody know where I'm going with this? When you do a column alias like that, yeah, you can. As long when you make a column alias, you can use that in subsequent clauses, as long as you use the same, the same alias that you gave it. Order by doom number. That should error, right? Oh, that ain't right. Doom number isn't anything. See, this is what happens when I go off script. Order by, and it's not doing it. It's wrong. I wonder if order by quote room number was also wrong. Yes. Order by room number was also wrong. So you can't do that. I'm getting ahead of myself. If we order by room, now we get the ascending order from low to high that we were thinking of. So we'll get into table aliases when we do table joins, but that gets you a column. That gets you a nice looking column header. It's what that's for on your output. So if you export that, let me put it on the desktop, and we call it term.csv. And we go back out to the desktop and click on term. Bam, there's our pretty column headers that we formatted in Workbench. So you can get everything all nice and, or, in the correct sort order. You can limit rows. You can do conversions. You can combine columns. You do all that cool wrangling in SQL, so that you don't have to do it in whatever next tool that you use it in, like Excel. Don't save. Okay, that's the end of single table queries. Try to think how to best use time. If we move forward with table joins, 10:45. I want to give you some time for homework, some time for the first SQL exercise. But it's a little early to quit. So I'm going to keep going. Okay, any questions on what we've gone over on the various clauses? Any examples, or but what about, or everybody's totally locked in on select, from, where, order by? I mean, there's other operators, other stuff, but all right. Okay. Well, I'll put that away and we'll go to the next file these are all loaded in the classroom. We'll go to file number 3, multi-table queries. And this is where it gets fun. I'm not sharing yet, am I? Okay. This is where you start to link tables together using that primary and foreign key construct that we talked about, where the relationships become critical. And this is how I learned this sort of stuff is with SQL. And when I learned it, VLOOKUP in Excel later, it just seemed kind of a little bit odd the way they do it, but it works. But here, we're going to do the first most simple type of table join. Joining is where you link data from two different tables by a field, by a key field, like student ID or faculty ID. And we'll have some examples. This should make perfect sense by the time we're done. Okay, and there's 2 syntaxes for joining tables that we'll go over. If you're used to using SQL, which some of you are way better than me, you might be looking for me to cover the join keyword first, but I'm not. I'm going to do the simplest one is to do it in a where clause, and you just tell the query what fields to join on in your where clause. And that looks like this. You select from one table a field name, and from another table another column. You have to list all the tables that you are selecting from in your from clause. Whether they're in your select or not, they may be in your where. But But if you use columns from a table in a SQL query, it has to go in your in a from clause, in your from clause. So in this most simple example, we're selecting a field from table 1 and a field and a column from table 2. You put the name of both tables in your from clause, and then you have to tell the database which field in table 1 you want to join with and or to be equal to over in table 2. And this is very often, like I said, like a parent-child relationship where, like we talked about, if you had employees and you had a unique employee ID and there was one row for each employee, but you wanted to track the cars that an employee was authorized to park in the lot, and there may be 2 or 3 or 4, whatever, however many cars in the car table, but each one has to have an employee ID in it. You would go get the cars from the car table, but you would join that query on employee ID to make sure that John Smith was listed against John Smith's cars, no matter how many there might be over in the car table. So that's how you you join those in the where clause. So that's a condition, right? Like we talked about, a condition of pulling rows back. But you can also add just good old search conditions, like where car is blue or whatever. So you're only pulling employees and their cars where the cars are blue. Okay, so we got some examples of that. Retrieving data from 2 tables. So select field name 1, field name 2. Those are going to be displayed. Remember, your output will only be columns that you list in your select statement. But it can be that that your from clause has tables that you're only using in a join condition. So yeah, we'll have some examples of that. Let's see. Select and from clauses list fields to be displayed and the tables involved. Yep. Okay, for example, our student table has the primary key of student ID 1, 2, 3, 4. But then you see over here, you've got an FID column that is their advisor, just like we talked about, their faculty advisor, and it can be blank if they don't have one assigned. So Sarah Miller, Brian Yamato, and Daniel Black all have faculty number 1 assigned as their faculty advisor. And Amanda Mobley has faculty number 2. And we can see that faculty number 1 over in the faculty table, which also has the same column name, F_ID. They don't, it's okay for them to be the same column name because you resolve the column name using table name dot column name notation, kind of like calling a method in Python. You say string variable dot method. Well, there's that dot notation is also how you tell SQL which one you're talking about. So student.fid is different than faculty.fid. But that's what we will use to link these 2 tables. Okay, and then remember back to our ERD, if you're got that open, you can see that that there can be each student has one faculty, but faculty can advise many students. So here's the key to those ERD symbols. This is just it's kind of like an ANSI standard notation. There's different standards for notation. I think this is the ANSI standard that you see in most of these ERDs. That's all those arrows that you see on that diagram. Okay. Retrieving data from two tables. Issue 1. What happens if you select a field name that appears in both tables? Suppose you want to display FID and the two tables are faculty and student. FID appears in both tables. Caution, you must qualify the field name in the select clause. So to qualify, you got to tell MySQL which table to use. Let's see if I can get this to come up. Okay. So if we were to select SID and FID from student and faculty, it doesn't specify which table, because FID is in both tables. It doesn't specify. And if we say select student ID and student ID dot FID, there's the resolution I was talking about from student and faculty, that resolves it. But the problem is we get, if you don't do a join, if you don't have a where clause with any kind of linking, you start to get crazy results. You'll get, I think I got it on the next slide, a Cartesian join, where you get a row for every other row. I'll have to get to it. So I think it's might be confusing you a little bit. Okay. So we can have our join field as well as other search conditions. So let's get to what this is called. This is called an inner join, equijoin, natural join. It's the simplest of kind, and it is the union of both tables. You'll wind up getting the FIDs that are in both tables. So you won't get any, if for whatever reason there was an FID in the student table that didn't exist in faculty, it would be disregarded. And if there's a faculty member that isn't assigned as an advisor, they'll be disregarded. So what you wind up with is the data that's in both tables. I think an example might be the best way to go about this. Okay, so we're pulling student ID and student first name and the FID from faculty. I'm sorry, from student. So it's the advisor, right? And then F underscore last, which is the last name from faculty. Okay, so we're querying data in our select statement from two different tables, from student and from faculty. Since there's a faculty ID in both tables, we have to tell MySQL which one we want to display, which is the student FID, because that's what you're displaying data about the student, their ID, their first name, the ID number of their advisor, and the last name of their advisor. But last name isn't in student, it's over in faculty. So you don't have to say faculty.f last. The query engine knows that if you name a column, or if you list a column in your select clause and it's only in one of those tables, you don't need the dot notation. It's only when it's in more than one table and it's confusing to the database engine that you have to put that dot notation. Okay, so we're selecting those fields from two different tables, and we have to put those two tables in the from clause. And then the link is in our where clause, where student FID equals faculty FID. Okay, so we'll run that and you'll see what we're talking about. We'll get a list of all students. Oop. Come on. So we're going to get a list of all students, the ID of their advisor, and the last name of their advisor, which is not in the student table. That's being joined over from the faculty table. So that's your simplest inner join, where you're grabbing data from another table and connecting it appropriately to data with another table. All right, inner join. Okay, let's keep moving on with that. Any questions on that? We may get to your if you are having questions, we may get to it. And then, like I said, there's the other syntax for this is to not do it in the where clause. You do the join with a join on syntax. So the exact same thing. I learned it. I don't think this join. I don't think the join syntax was there 34 years ago. So I learned to do joins using the where clause. So that's what I'm just, more comfortable with. But I think most folks that are learning SQL now are more comfortable with inner join. Can you guys that are more experienced with SQL comment on that? Are you more comfortable doing it with the where clause or with the join clause?
Everything I've seen uses the join clause.
Yeah. So that's
Yeah,
probably,
me too.
there you go. So that's like a trip down who cares memory lane for you guys. But back in the old days, that's how we did it. So yeah, from the student, inner join with faculty. So that means you're joining student and faculty, and it's an inner join, which means give me records that that are in both tables. We'll also go through a left join, a right join, and an outer join, which are ways to grab data that's only in the left-hand table, which in this case would be student, or the right-hand table, which would be faculty. And it's a way to do kind of like looking at a Venn diagram, either unions or stuff that's only in the right-hand table and the left-hand table. Anyway, same syntax, same results. Blanchard, Baines, Williams, and Cox. I wanted to see here real quick. I think I'm getting ahead of myself, but I'm so curious. I can't wait. I'm going to pull student ID or student FID, because you don't really care generally what Blanchard's faculty ID is, right? I mean, generally. So I'm going to pull that out of the select statement. Yeah, you don't need the join fields to be in the select statement. I just wanted to make that clear. I think I cover that later, but like I said, I got curious. Okay.
If you're doing it with the where, would it still need to be in the select statement?
Oh, let's go back and do it. That's a good question. I don't think so. I don't think you do. There's a lot of things that you can do in where and order and whatnot that they don't have to be in the select statement. So here we go back to that syntax. So let's get rid of student.fid. Yeah, it doesn't have to be in there. See that you don't have to display it in order for SQL to operate on it. I guess that's the takeaway. Okay. Where were we? Yeah, this is just going back and reiterating that. There's several types of the fields in the query, depending on how I use them. There's the display field. And that will always be in the select statement. Those will be displayed. And they will always be displayed. And the ones you use in your other, in your join fields, your search conditions, don't necessarily, or they don't have to be in your select statement. But they determine which rows are displayed, not which columns are displayed. There you go. There was another curiosity I wanted to check real quick here. Let's see. Okay. I want to order by. It seemed like I'm trying to remember, and I'm probably getting ahead of myself. It seems like you can order by something that's not displayed. Let's order by student.f_id. So this could change the order. Blanchard, Baines, Cox, and Williams. No, it seems like you can order by stuff that's not displayed. Blanchard, Baines, Cox, Williams. Baines, Williams, Cox. There you go. So yeah, you can order by fields that are not displayed if that gets your data in the order that you need it for later processing. There's a lot of instances like that in SQL that you don't have to display something that you are using to manipulate your query. All right. Let's try another query. Display the course section ID, the section day, and status for all of the terms where status is closed. And this is starting to show you we're back to joining with the where clause. Let's see here. Punch that in. 1108. Okay, so that'll pull up. CSEC day is like MWF is the class meets Monday, Wednesday, Friday. TR is Tuesday, Thursday, and so on. And we're back to using the where clause. I wanted to go off. And you see here status again. Status is in blue, but it does not error. I want to say there was a syntax for doing that. to make sure that you tell the database that it's the column you're talking about, not the keyword. But this works okay. So let's go off script here for a minute here, guys. If I wanted to change this syntax to the join without looking, so I'm going completely by memory here. Our where would just be where status equals closed. So we would say from course section, boy, I'm trying to do it from memory and using the join syntax. From course section, yeah, I can't, I cannot remember without looking. The join syntax from table 1. That's not it. Where was our join syntax? What screen was that on? Join on. What? What screen was I on when we use the join on? No. Good grief. Yep. 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 There it is. Inner join, then the second table number. Okay. From course section, inner join term on. So we're still going to have to change this and to where and change this to a on. Does that look right? Inner join from course section, inner join term on course section term ID equaling term ID. Yes. There you go. Like I said, guys, I can never remember the syntax of this stuff. And I almost never just am able to keep typing. So I hope you are Googling, using examples, you know what I mean, whenever you're working on these exercises and not trying to do it from raw memory. But there is a clumsy conversion between using the where clause for the join and the actual inner join. Let's see what not equal closed. What other data we got in there? Ah, the ones that are open. 3 that are open. Okay, let's see, where were we? Verve. There we were. Okay. Multiple table queries are essentially the same as 2. Yeah, depending on the complexity of your relationship of your data, you can join more than 2 tables. You can join however many you need to. It all depends on that relationship. So it is the same process. However, you must include all join fields, not necessarily in the select clause, but you do have to use all your fields. You have to do all the linkage. And sometimes you must include intermediary tables in join fields to get the desired field to display, even though they're not, just like I talked about. You know, you can order by stuff that you're not displaying. You can sort data by some other field. And it's not part of your displayed data. And the same goes with multiple tables. So here we're going to write a query that lists. Let me see how much further I'm going to go here. I think I'm gonna stop. Yeah, I'm gonna stop there because joining two tables will get you through a good bit of the homework exercise. So I'm going to give you this last hour. And let me go to the classroom and show you what I'm talking about here. Give you this last hour to do SQL Query Problems 1. If you go to Canvas and click on this assignment, you will find a Word document that has a brain teaser starting from single table queries, and it'll get you practicing, sorting and filtering data. And then around problem number, well, I'll click on it. Hey, instead of just talking about it, I'll show you. Yeah, and starting with number 6, and this is all on the same Northwoods that we've been working with. It starts to join two tables. So we're gonna quit here today, use the rest of this hour to work on this assignment. But before you go to lunch or quit for the day or whatever, turn in, please, this file and make sure you put your name on it. Regardless as how many you were able to solve. If you were able to solve none or you're able to solve them all, please turn this in at 12:30, because I'm going to go in this afternoon and see how everybody's doing. And when you don't turn in anything, and I know there's 6 of you here today, it makes me scared. I'm wondering what's going on. So yeah, that's the last hour of the day. Work on those SQL queries number 1 in Workbench. And Seth, I don't know, you're pretty comfortable with SQL. If you want to take a guess at them, I'll run them for you. I know you're having trouble getting Workbench up and running. Take a guess at them, turn something in, and then, like we talked about, you may need to work on them from home to get around firewall restrictions. Does that sound like a good enough deal, Seth?
Yeah, I mean, looking at them, I think I should be able to get pretty close. The syntax for MySQL is probably a little different than Postgres, though, so there might be some issues with that.
Okay, so yeah, like I said, do as good as you can. I'll run them for you, let you know what I come up with, and then you can email yourself whatever your file at home and correct whatever little deviation there might be between Postgres and MySQL. All right, I will stay online after we dismiss. Any other questions, concerns? Everybody know what I'm looking for? All right, I'll let you go, and we'll see you Thursday morning for more of this stuff. Thursday morning at 8:30.
Thank you.
Thank you.